In this section, there will be an introduction to functions, what are functions, what consists of a function, and we're going to also look at their graphs, what makes a function. So let's look at some terminology, some vocabulary. We have here the definition of a relation. A relation is a set of ordered pairs. And in a relation, you have what's called a domain and range. The domain is the set of all first components of the ordered pairs, and the range is the set of all second components in of the ordered pairs. So, for example, we'll go back to what's a function, but let's just look at what is a relation. And remember, a relation is a set of ordered pairs and ways that we can represent that relation. So, as we cover these sections here, um, when we talk about independent variable, it's the variable x, which is called the independent variable because it can be assigned any value from the domain, and the dependent variable, which is the variable y, okay, because its value depends on x. So a function is a correspondence from a first set called the domain to a second set called the range, such that each element in the domain corresponds exactly one element of the range. So let's look at some examples and then we'll go back into the definitions. So ways to represent a function. Remember, it says a relation is a set of ordered pairs. So here is one way. We can write it as a set of ordered pairs. For example, we have 4, 4, 4, 6, 9, 4, 9, 6. Okay, and from that, we can identify the domain and we can identify the range. Another way that we could represent a function is by graphing or plotting the points. Okay, so we can plot the points here. So we have 4, 4, we have 4, 6, we have 9, 4, and we have 9, 6. Okay, so we can plot the points. And we'll talk about, if you choose to plot points, what test will you use, or the test that will be used to determine if this relation is a function or not. Another way, we can create an input output table. So our first ordered pair, we have 4, 4. If we input the x coordinate of 4, then the y is going to be 4. 4, 6, our input is 4, our output is going to be 6. Our input is 9, our output here is 4. And then 9 again, our output is 6. So we can create a table. We can also create a mapping diagram. And it's going to be here again a way of showing, identifying the domain and range from that relation. So to identify the domain, if you have a number that repeats more than once, you only need to write it one time. So our domain in this set of or in this relation, we have 4 and we have 9, because remember the domain is all of the x coordinates. And then our range, we're talking about all of the y coordinates. And if we have any that repeat, then we only need to write it one time. We have 4 and 6. Okay, so when we map, it's just like we're pairing. What pairs with, let's look at the first set, this ordered pair. What we have the independent variable of 4, what will be the dependent? Or what pairs? What will be the domain and its range? So we have 4 pairs with a 4 here. And then we have 4 being paired with 6. So let me just stop here for a second because I want to talk about again what is a function. It says, going back to your notes, a function is a relation in which no two ordered pairs have the same first component and different second component. A function can have two different first components with the same second component. So basically what this is saying, your x value can only be paired with only exactly one y value. Now, as we look at this example, this 4 is being paired with the 4 and the 6. That's not what we want. So if we don't want that, we would say that this is not a function. Now, if you want to, we can map the 9. 9 maps to 4. And 9 also maps to 6. And because 9 is mapping to 4 and 6, it's not a function. Okay, so I'm going to write down here that this is not a function. So I just want you to see that depending on the question, there are different ways that we can represent a relation, a set of ordered pairs, by listing the ordered pairs, by plotting points, by creating an input-output table, mapping, we can use it. And don't forget, when we talk about domain and range, because you're going to hear this word a whole lot in this course, domain, we're talking about the x values, and the range, we're talking about the y values. We can say input, you may hear input, and your y value being your output. Another way, instead of x values, domain or range, you may see where it says the independent variable, which means the x to the dependent variable, meaning the y. So become familiar with the different ways of representing or saying domain and range. You may see it depending on the textbook. It may be written Each textbook uses it differently, but what's going to be consistent, domain and range. Domain meaning the x value, the range meaning the y value.